Hi there, this is Space Nuts Q&A. My name is Andrew Dunkley. Great to have your company. Coming up on this episode, we'll answer questions from Steve, Gus and Nick. Steve and Gus are sort of focused on the same thing, gravity. Steve wants to know if it can exist without mass. And Gus is talking about gravity and energy and what's the relationship. And Nick is asking about galaxy movements and are any moving towards us that we can't see yet? Well, we don't know. We can't see them yet. But we'll see if we can tackle all of that on this episode of Space Nuts.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Here he is again, Professor Fred Watson. Hello, Fred.
Hello, Andrew. Hello. How are you doing now?
I'm doing the same as I was before. How about you?
Well, I'm still doing the same as I was before. Yes, that's right.
Yeah,
and I hope to be doing the same again very soon.
Yes, indeed. Yes. So shall we just sort of muck in and get these questions sorted out? It was like a couple of weeks ago, we had gravity questions coming in thick and fast. No, black hole questions, but today it's gravity questions.
It is.
And
yes.
our first one comes from Steve.
Hi guys, my name's Steve. I'm from New Zealand. Really enjoy your show. Recently read a article implying that gravity could be possible without mass. And I'm wondering if that would be another alternative explanation to dark matter and to MOND. Yeah, I don't know if that makes it very clear to you. Anyway, thanks.
All right. Steve, thanks for the question. Gravity without mass. Well, I doubt that we can turn to the Catholic Church because they do have mass, but it's terrible. It's an interesting question, though.
It is, and so yeah, my reading on this, excuse me, is yes, that's correct. So actually, there's a nice thread about this on Reddit. If anybody looks at that website.
I do,
and
I love Reddit.
Yeah, really. I do remember my one of my sons was an absolute Reddit fiend at one time. He was very much a Reddit fan. Now, so that's how I was aware of it. But I haven't been a great user of Reddit. But the bottom line, excuse me, is. And this is the way it's phrased in this particular conversation. If you increase the temperature of an object, and they take a planet in this case, and in fact, I might just read it because this kind of is quite interesting. Take your Neptunian planet, something the size of Neptune. Raise the temperature by 300 degrees Kelvin instantly. Now, the mass of Neptune is about 10 to the 26 kilograms, and if we roughly assume all its hydrogen corresponds to about 6 times 10 to the 52 particles of hydrogen, the thermal energy is roughly given by an equation there, E equals NKT, which leads to an increase in thermal energy of and it's a large number of joules. Actually, it's a small number of joules. It's K times 6 times 10 to the minus 52 times 300 joules, which if you then convert that, so what this is saying is you warm up a planet, you get an increase in the thermal energy of that planet. You can then use E equals mc squared to convert that thermal energy into mass. And in this case, it comes out to be something like 3 times 10 to the 15 kilograms, which is a lot, but is not very much in comparison with a planet. But that does mean that adding energy to something will increase its gravitational mass. Now, Steve's sort of, next step in the argument from that is whether that could be misleading us in the idea of dark matter and things of that sort. I can't really get my head around how that would work. He mentioned MOND as well, the modified Newtonian dynamics, because my understanding is that everybody who looks at these particular problems, what is dark matter, what is dark energy, they take into account everything. I've read some of the papers on this, and so things like gravitational influence of pure energy, and in this case we're talking about heat energy, that is likely to be something that would be already in the equations. So I don't think it's the answer, but it's a really interesting suggestion and an interesting thing to think about. So thank you very much, Steve.
Yeah, indeed. Just made me wonder, are we increasing Earth's gravity because we're heating the planet up?
Yep, that's probably right. The example that I just read out was about 300 degrees Kelvin, an instant increase in that. We're talking about 1 or 2 degrees Kelvin, but which makes a big difference to the Earth's atmosphere, but probably not that much difference to its gravitational potential.
Okay, so the answer is yes, gravity can exist without mass, but it's probably not a major factor. Is that fair enough?
Yes, that is right. I've just been dragging through my memory, Andrew, something else that's sort of vaguely related to this, which is well, we haven't used this name, but we did talk about it a while ago, the Kugelblitz. Do you know what a Kugelblitz is?
Look, I've heard this before.
Yeah.
No, remind me.
Yeah, so it basically is a black hole made of light. And Wikipedia says it's a concentration of heat, light, or radiation so intense that its energy forms an event horizon and becomes self-trapped. In other words, if enough radiation is aimed into a region of space, the concentration of energy can warp space-time so much that it creates a black hole. It's a black hole. It as a black hole whose original mass energy was in the form of radiant energy rather than matter. Now, there is a paper that was published in 2024 that concludes that a phenomenon like this cannot occur in any realistic scenario within our universe. So Kugelblitzes are a theoretical entity that are thought not to occur in nature. But it is a similar thing, isn't it? It's a black hole made of energy.
Yeah, wow. That's really interesting. I'll tell you, something else that does exist is a Kugelschreiber. So I've got one of those.
Have you?
Yeah, there it is.
Hang on.
It's a pen. It's German for pen.
Hold it up. Ah, okay.
Kugelschreiber.
A Kugelschreiber.
Yes. Do you know what German is? You know what the German is for pencil?
I probably did once, but I don't now.
Yeah. Bleistift.
Bleistift. All right. There you go.
It's probably. I did languages at high school, and I was very good at them, and I should have probably pursued that somewhere along the line. But German stuck with me. Some of the references I still remember today. Someone's going to correct me now because I've probably buggered up the pronunciation. But anyway.
That's all right.
I'm just showing off now.
It's a side of your character that I was unaware of, Andrew. Curiously, I never joined Lerman at school. I never learned German at school. But when I was 14, I went on a school exchange to Germany, which was bonkers because I wasn't studying German. But that was my first overseas visit, of course, from the United Kingdom. And so I've spent the however many years it is, 60 odd years since then, trying to learn German. And
Yeah, look, I'm so jealous of students in countries like the United States and the UK and Europe because they get to do excursions to other countries. In Australia, we got to do excursions to Sydney and Canberra. I mean, come on. That was it.
Yeah.
That was as good as it got for us.
Yeah.
I mean, these days they get to go to New Zealand once in a while. But yeah, we're so far from everywhere. It's just not easy. Although my son did get to do a couple of weeks in Japan through high school.
There you go. There you go.
There are a few options these days.
Yeah.
This is Space Nuts. Andrew Dunkley here with Professor Fred Watson.
Let's take a little break from the show to tell you about our sponsor, Incogni. And if you've ever had your information harvested from the World Wide Web, this is the tool for you. Of course, your information is easily available online. We're talking personal information. We're talking addresses, phone numbers, email addresses, even bank details if your protection isn't good enough. This stuff gets harvested and it is sold by data brokers. They sell it to other people who then scam you or other people in your name, which is happening a lot. I've found my information on the dark web on several occasions in recent years and managed to clean it up. But the more I clean it up, the more I have to clean it up because it just keeps going around and around and around. Chances are you regularly get those shonky emails and texts about winning something. That's a common one. Or your mail being lost, the package couldn't be delivered. Could be anything. Could be anything. And, of course, there's a link on these very handy emails and texts to help you out. But it's actually the opposite. They are basically hoping you'll fall for it and give them information that will now then enable them to scam you to the tune of hundreds or even thousands or, worst case scenario, tens of thousands of dollars. And there's been a lot of cases of that in recent times. In fact, in 2022 alone, the number of scams rose by 41.5% globally. So what is the solution? Well, the solution is you can go online and clear out your personal data by yourself if you've got a couple of years up your sleeve, because that's how long it will take you. And that's not a joke. It will take a couple of years. And when you've done it, of course, other information of yours is already back online. They just keep collecting it regardless. Or you can use a ready-made solution, and that is Incogni. And as a Space Nuts listener, you get a special deal with Incogni at the moment. It is simple. It works in the background. It provides ongoing protection, so you can sit back, relax, and know that Incogni is protecting you from these harvesters and scammers. And all you have to do is create an account, give Incogni permission to work on your behalf, and that's it. Job done. And if you want to check out the pricing, there's a 60% off deal for Space Nuts listeners at the moment. That is fantastic. Just go to incogni.com/spacenuts for more information. That's incogni.com/spacenuts. And look at the pricing for individual plans, or you can get a family and friends plan. Just depends on the circumstances. But at the moment, 60% off the annual individual plan and 60% off the family and friends plan. Check it all out at incogni.com/spacenuts and see what works for you. But peace of mind is probably, something that we all need in this world of data thieves. So check it out today, incogni.com/spacenuts. Now back to the show.
3, 2, 1.
Space Nuts.
We better keep moving. Thank you, Steve. Let's get a question from Gus.
Hello, Professor Fred and Andrew. This is Gus Iverson from Issaquah, Washington. I sent in a question for you guys previously, and you thought I was in Western Australia.
Yes.
I've been thinking about gravity today, and it came to my mind that if energy and mass are equivalent, then essentially, shouldn't energy also create gravity at some level? I'm not sure if this is a related question or an extension or a separate question, though. Additionally, if a body of any size is generating or has mass, and it is generating a gravitational field, does not that field itself have energy and mass? And would that field not create additional gravity by its simple existence? So if that's the case, or even kind of the case, my question is, where does the energy and mass go I have no idea where to go with this. Thank you. I love the show and appreciate being able to ask questions.
Thank you, Gus. That sounded very much like something from Catch 22.
Yeah,
was it apples or tomatoes they were trying to? I don't know, it sounded a bit like that. Gravity plus energy, body plus mass plus gravity equals energy. But then, does that add mass, which adds to gravity? I think that's what he was trying to.
Yeah, that's right. So you've got the whole thing gets completely out of hand because everything's got gravity. I think so. The first part of what Gus was saying is what we've just been talking about. If you equivalence of energy and mass, and gravitation. I probably have to be careful with the words. Gravitation is a potential. An object in a gravitational field has potential energy, so it does have energy, but I kind of need to take this one and notice. Actually, you did give me notice, Andrew, but I didn't have time to really look further into it. But I think there's a stumbling block somewhere in that argument, which is probably that gravitational energy isn't energy that's convertible to mass. But I need to get my thoughts clearer on that, which they aren't at the moment. So, Gus, thank you for a very tricky question, which I might think a little bit more about. Perhaps we will revisit it in a future episode of Space Nuts Q&A.
I've put a homework marker next to it.
That's pen. What I'm just doing that. I'm doing it. You're doing it in your Kugelschreiber?
I'm using a red Kugelschreiber.
Okay.
Yes. I don't know what the German word for red is, though.
Vote.
I could probably do it on Translate, though.
It's vote. Vote. R-O-T.
Oh, there you are.
Yeah.
There you are.
Yeah.
I don't have to look it up.
You don't. No.
So, Gus, don't know. We don't know. Maybe, possibly, could be, don't know. There's the answer.
Don't yet know.
But
How's that?
Don't yet know. Very good, Fred. Yeah. I like that.
Yeah.
Let's get to the final question. We'll get back to you, Gus, at some stage in Western Australia, or it could be the United States. Now, we've got a question from, just by coincidence, from New Zealand again. Hi, team. Amazing podcast. Which one are you talking about now? I have been listening since your early days and have always looked forward to new uploads. My question is around the discovery of early galaxies from the James Webb Space Telescope. Is it possible for earlier galaxies to be travelling towards us that are currently out of reach, filling with potentially nothing, filling where potentially nothing was in view before? If possible, would the light be compressed? How would the instruments deal with that? Hope that makes sense. Cheers, Nick from Auckland, New Zealand. My brain just went, well, I suppose it's possible, but how do we prove it until it happens?
Yes, so a couple of things in here. Thanks, Nick. Great question. The last bit about light being compressed. So, and in a way, that's quite a nice way of putting it. So anything that comes toward you that's emitting light, its light will be blue shifted. In other words, its wavelength will get shorter, and that's saying it's compressed. It's pretty well. That's pretty well what happens. It's like, the good old ambulance siren or fire engine siren or whatever it is coming towards you, which compresses the sound waves, and the result is an increase in pitch, which corresponds to a shortening of wavelength. So that's standard physics. We can detect by the Doppler shift anything coming towards us by the fact that its light is shifted towards the blue end of the spectrum. But the first bit of the question about galaxies, earlier galaxies traveling towards us. When we think about galaxies, we have two different velocities involved. One is the velocity of a galaxy as it's carried along by the expansion of the universe. And that is what we measure as a redshift. The expansion of the universe is carrying galaxies away from us, and so their light is being redshifted. And by the time you get to these really early galaxies, where you're looking back almost the whole age of the universe, the redshift is very considerable. It's a factor of 13 or 14, something like that. We're giving a name, Z. The redshift is about 14. So I beg your pardon, no, that's not true. That's me confusing the age with the redshift. Forget that bit. But the number's quite high. The redshifts are probably 5 or 6 or something like that. But it's still a high level of the light being stretched out by the expansion of the universe. So that's one velocity. But galaxies can have a superimposed on that a velocity which we call a peculiar motion, its own velocity. Caused by local eddies in space or whatever that might move a galaxy towards us. It's the gravitational field that it's exposed to. Very much like the analog is always a river carrying you along. And if you're in a rowboat, you can move relative to the river, but the river's always carrying you along. That's exactly what's happening with the Hubble flow, the expansion of the universe. And these peculiar motions are superimposed on that, but they're much, much less than the motion at those distances or look-back times. It's much, much less than the expansion flow of the universe. So, no, there won't be anything hidden from us that's coming towards us, I don't think. It's an interesting suggestion, but everything's moving away from us at this very high velocity at those distances.
Of course, Nick, if you want to check with us in a million years or so, we might have an alternative answer.
Well, that's true. Put that in your diary, and I'll mark it with an asterisk, knowing that it's homework for a million years' time, Andrew.
Yes, it's good. And I'm really disappointed that the people who make diaries haven't gone ahead that far yet.
That's right.
Really. Thanks, Nick. Probably not, I think, is the answer. But thanks for the question. Thanks to everyone who sent in questions. Keep them coming. You can do that via our website, spacenutspodcast.com, spacenuts.io, which has two options. The AMA tab at the top, where you can send us text and audio, or the send us your questions button on the right-hand side of our home screen. Don't forget to tell us who you are and where you're from, and you can probably upload your audio questions on any device as long as you've got a microphone. Mobile phones are perfect for this, but a lot of people have home computers with mics built in, etc., etc., etc. Always happy to hear from you. Fred, thanks so much. We're done with another episode. Geez, we're wrapping them up.
We are wrapping them up. Good to talk to you, Andrew, and we'll speak again soon.
Indeed we will. Professor Fred Watson, astronomer at large, and thanks to Hugh in the studio for collating not much, but we thank him anyway. And from me, Andrew Dunkley, thanks for your company. See you on the very next episode of Space Nuts. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Available at Apple Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.